Hi there, my name is Matthew Carson with the Open Source Energy Network. We're very excited to be bringing these testimonies before you today, but first of all we'd like to thank the Disclosure Project. The Disclosure Project has spent a couple years and over $250,000 acquiring these exceptional energy testimonies from trailblazers in the clean, free, renewable energy field. These testimonies are testimonies. They aren't simply interviews. They have been documented with affidavits and documented credentials. These people have important things to say about the current state of energy as it is in the world today. Please listen carefully, watch carefully, share these videos, disperse them amongst your friends, email the links around, but make sure to donate directly to the Disclosure Project today, and keep in mind that these are not fictional interviews or showbiz articles. These are testimonies that we hope, and the Disclosure Project hopes, will eventually stand in a court of law. Thank you.
Okay, one of the discoveries that emerged out of modern quantum theory is that so-called empty space isn't really empty at all. It's actually full of energy. So instead of being like kind of a quiet, empty lake, it's more like the froth at the base of a waterfall or something. And this energy is basically electromagnetic in nature, and the energy density is quite high. In fact, it's so high that when it was first discovered mathematically, it was thought to be some kind of artifact of the mathematics. But then as time went on, there were even Nobel Prize winning experiments that showed that this energy in so-called empty space was really there. We don't usually notice it because it's so homogeneously distributed. It'd sort of be like sitting in a bathtub with at exactly your body temperature. You might not notice the water. But under certain circumstances, it can be disturbed or perturbed, and then it has effects. As I mentioned, some effects on atomic emission, for example, is what eventually ended up in a Nobel Prize for Willis Lamb of Yale University. And it's called the Lamb shift. And this is a recognition that, in fact, this energy disturbs atoms. So atoms aren't sitting in a void, they're sitting in the sea of energy. So once quantum theorists realized that energy was there, the next question was, well, is there any way to tap it? And it was thought originally that probably not. It might be like trying to tap the heat energy around us. And you can quickly prove for thermodynamic reasons that it'll take more energy to tap it than you'd get out of it, so you don't come out ahead. But back in about 1984, a researcher at Hughes Laboratory by the name of Robert Forward showed that there was a particular effect called the Casimir effect, which demonstrated that in fact this energy could be tapped. Well, when you go to look at the numbers, you find out that there's enough energy in the volume of a coffee cup to, say, evaporate all the world's oceans if you could get at all of it. So this raised the issue among theorists. Well, can we manipulate this energy? Could we tap it for spaceflight application, for example? And there are a couple ways to go. Could we get propulsion out of it? Could we use it as an energy source? And so these are the areas that modern theorists are looking at. But one of the more interesting aspects is that if in fact it does look like there's a route from here to there, then we consider the possibility that, well, maybe there are other civilizations who've been down this track ahead of us. And so it opens up the possibility that you can't reject the possibility of, for example, ET visitation out of hand. And, you usually hear where Einstein said you can't go faster than the speed of light. Well, that's something out of special theory of relativity, and it really is that you can't take an object and speed it up and then through the light barrier, because it would take an infinite amount of energy and mass to do it. But it turns out it's a faulty conclusion to say, therefore, you can't go faster than the speed of light, because once you get into general relativity, you have some options. The options are to change the properties of space itself, so that locally, the velocity of light is engineered to be faster than the usual value. And the best way to explain how it is, how it comes about, is that it's actually the idea of stretching space, expanding space on one side of the craft and shrinking space on the other, so that you're not only moving forward through space. If the space itself is like moving forward on a rubber sheet while at the same time you're pulling the rubber sheet and expanding it. So then relative to the outside environment, you can be going at, say, the speed of light along the rubber sheet, but if the rubber sheet itself is moving relative to the rest of the universe, then your net motion is faster than the speed of light. And so the implication then is, well, if you can manipulate this zero-point energy C, get it out of the way, then if something tried to accelerate you, it would be easy. You would have no, quote, inertia. It'd be, rather than using humongous amounts of energy to try to propel you through this tremendous force drag that you get from the vacuum fluctuations, you could throw BBs out the back, I suppose, and take off like a shot. And so, in fact, the Air Force was sufficiently interested in that they set up a program called Mass Modification, in which I and my colleagues were interviewed to find out all the details of our modeling inertia as a vacuum fluctuation phenomena that might in principle be manipulated, to see if there was a possibility in some far distant future of reducing the inertia of a spaceship so that ordinary propulsive means could be used with relatively low energy requirements. And so they did a year-long study and went around to various universities and laboratories and asked people to tell them about experiments they might be able to do to determine whether our model was correct. So again, there's another indication that these are not just fringe scientists with science fiction ideas, but that basically these are kind of mainstream ideas being published in mainstream physics journals and being taken seriously by mainstream military and NASA-type funders. A whole volume of space would be in a special state, so the pilots, for example, would not feel inertial forces either. And so under those conditions of promoting a situation in which you get rapid inertia of a spaceship, the people inside would, under those same space-manipulated conditions, not feel tremendous inertial forces. Here at the Institute for Advanced Studies, one of our main interests is exploring the possibility of tapping or mining this vacuum fluctuation energy, zero-point energy. By the way, we call it zero point because even if you froze the universe down all the way down to absolute zero, where most motion would be frozen out, this energy would still be there. It's a very fundamental kind of energy. But we're looking to see if we can extract it for many uses, not just spaceflight application. I mean, the grand outcome would be that if you could use it to power everything from electric toothbrushes to aircraft carriers to automobiles to homes to space flight. One of the main areas of interest, actually, in terms of potential use that we've been approached by many people, is the possibility of having a very cheap energy source for desalinization. It's very hard to make antimatter in large quantities and keep it bottled up, but it has been done. Antiprotons have been generated in accelerator experiments and then captured and kept contained for some periods of time. So that's an area that I know the Air Force has been interested in and pursues research on. Sometime before this millennium is out, I'm certain that probably that will come to use if there aren't other alternatives that are simpler. I routinely make presentations and briefings to various branches of the government. I've been taken out on aircraft carriers by the Navy and shown what it is that we have to replace if we have new energy sources to provide new fuel methods. Of course, NASA is funding some of these breakthrough propulsion physics ideas. The Air Force, various labs in the Air Force are pursuing fundamental studies on these kind of exotic ideas. So there's a lot of government interest. It's getting to the point where modern theoretical physicists are loath to rule out any possibility. I mean, now we're talking about parallel universes and membranes of many dimensions, and I mean, the physics is just getting as wild as it can possibly be. And sandwiched in among all those alternative possibilities is the possibility that some of these concepts might actually play a role in spaceflight application, where civilizations, ourselves in the future, or maybe more advanced ET civilizations at present, could perhaps travel long distances in relatively short times. Of course, we see claims, and not just among the public, but among military pilots and good observers, typically in the military, that there appear to be something like craft flying around with anomalous behavior. On the other hand, in terms of some of the characteristics that seem to be attributed to them, and giving the kind of physics and direction physics is going, you can't rule out that well, maybe some are some kind of craft or probes, maybe even more likely probes and craft from some faraway civilization. Of course, one of the intriguing things as we start looking into the possibility of reducing inertia and so on, and then you see these supposed sightings in the sky which turn on a dime, right angle turn, and so on. And the reason we used to reject those out of hand was that it appeared to be there was no inertia there. And until recently, that was sort of an inconceivable idea to a physicist. So I think a physicist is probably pretty justified in saying, you know, that doesn't sound like anything I can imagine to be a craft. Could imagine it to be some form of plasma phenomena or whatever, but not a craft. And so now, as we get this new evidence of, well, okay, maybe inertia can be modified, then it does make you sort of sit back and take a second thought about it. But when you consider that our electromagnetic technology is, you know, a century old, basically, and then realize that you could have advanced civilizations out there that are millennia beyond us, there really is no way of saying whether they might have some other way of making contact or find other ways like wormholes of just sending probes here or whatever. It could be well beyond our imagination. Well, the case that NORAD has uncorrelated targets that they can't account for. And from time to time, satellites see things called fast walkers. Seem to be energetic signatures moving faster than can be accounted for by known planes, for example. The fact that people of some credibility and credentialing are willing to come forth and say, despite the giggle factor for this area, we think there's something there that should be taken more seriously. Well, it's another mark that kind of an idea whose time has come to take this seriously. You know, scientific analysis, that this should not be an area considered taboo by modern scientists.